that I've opened up the software in a Chrome browser. No installation is required for the individual user level. And we also saw that this particular software is based on R programming, such that you don't have to write a single line of code, yet you can access the computation power of R. So there are no hassles of R programming if you use STATCRAFT, which is one of the biggest advantage for the users who are not very much inclined towards the programming world. So what we are trying to do is that we are trying to put together the best of both the world, the programming as well as the menu driven interface. And that's how we came up with the product called StatCraft, which is a mix of both the world, the best of both the worlds. So today's session, we will be starting with hypothesis testing, and we will be starting with the t-tests. So you see, in this session, we won't get much into the theoretical aspects because you know the challenges of teaching theory in an online platform. So I've tried to keep this session as interesting as possible. So we have taken up different case studies, and we will see what would be the best technique to solve those case studies. So we would be following a bottom-up approach. So first we would be solving the case study, and then we would end with the definition of that particular analysis. So the first case study that we will deal today is based on the independent sample t-test. So I'll just pause for some time. You can just have a look at it, and then we will start with the analysis. Okay, so I feel you have been through this case study. So I'll discuss it once again with all of you, and then we will start with the analysis. Okay, so as we saw yesterday that StatCraft, to access StatCraft, you need a user login and a password, and providing the credential, you can get access to StatCraft from anywhere around the world. So you don't have to be physically present in your campus. So like other software, you have to come down to your campus. But in case of StatCraft, you can access it from anywhere. So it has an advantage of accessibility over other softwares. Now what I'll do is that I'll just import the relevant data on which we will perform the analysis. So as we have seen yesterday, that you don't have to import your data every time. So once imported, the data gets stored in the server, and the data is protected by your user ID password. Okay. So from where we can access our data, so you see in the right hand side we have the view tab, and under view tab we have tables. So tables is generally an inbox for your data. So whatever data you upload, all of it gets stored under the table section, and all of this data are stored in the server. So you don't have to worry about your data security, because you see this server will be your internal server, means your university server or your department server, and this server will be maintained by your own IT team. So we as a company don't have any access to this server, and your data is protected by your user ID password. So there is no fear of data piracy. So as you can see, these are the different data that I have uploaded in the past, given against their respective date of upload. Okay, so I'll take the relevant data on which we will perform an independent sample t-test. So you see, this is the data on which we will work now. And as you can see, this data was uploaded back in the month of June, and now I can access this data from any system, even from my mobile. Okay, so it's just like your mail. You can access your mails from any device. Similarly, you can access your data from any device. So you see, I just click on the data, and the data gets uploaded in the STATCRAFT interface. I just click on this value label. Okay, so here we see the value labels. Okay, what does 0 stands for? What does 1 stands for? Okay, now coming to the case study. Now you see, often when we go to stores like Big Bazaar or Reliance, they come up with different offers. Okay, now similarly, there is this particular departmental store which has come up with two types of promotion: a standard promotion and new promotion. Now, in standard promotion, the customer gets a certain set of benefits, and in new promotion, the customer gets a certain set of benefits. Now, the store wants to understand that which promotion is fetching in more revenue. So, whether given a standard promotion, people will spend more, or whether given a new promotion, the customer will spend more. The store wants to find out. So what the analyst at the departmental store has done, he has randomly picked up 500 customers. Now the stores can have thousands and thousands of customers. So the analyst has randomly picked up 500 customers. To 250 customers, he has given a standard promotion, and to other 250 customers, he has given a new promotion. Now remember, no customer will get both type of promotion. Either you get a standard promotion or you get a new promotion. So you see here, customer with ID 148 is getting standard promotion, and he or she is spending $2,232.77. Similarly, customer ID 572 is getting new promotion, and he or she is spending $1,403.80. So similarly, we have this expenditure made by all the 500 customers. Now let's check out the basic descriptive statistics first. Okay, so how to do it? We click on analyze, compare groups, and what we want to check out, we want to check out the group descriptive. Like we want to check out the group means, like x1 bar, x2 bar, and so on. So we go to group descriptive, we give a analysis title, suppose subgroups. So you can give anything, xyz. I take the factor as the type of promotion, whether they are getting a standard promotion or a new promotion, and the variable as dollar, how much they are spending. In the function part, I want to check out the mean. Okay, having done that, I just click on OK. Now, just to mention again, so you see all this output comes with their respective R codings. So you can always copy this code and you can reflect the same analysis in R. So yesterday we have seen it. Also, you see, you can mention this R code in your research papers, journals, articles, and so on. Okay, so let's do one thing before going into this. I'll quickly change the folder. So you see, now we will be working with the t-test. So what I'll do is that I'll quickly create a folder called t-test so that all the outputs are there in a single folder. I click on sample, click on OK. So you see the folder has been created. I just select it, click on OK. So you see the folder gets activated. Okay. So here you see the folder has been activated. Now let's do the descriptive once again. So again, I'll repeat it. I click on compare groups, group descriptive. So all this remains the same. The function is mean, and click on OK. Now here you see 250 customers are getting standard promotion and 250 customers are getting new promotion. Now you see the customers who are getting standard promotion, how much they are spending? $1,566.38. So this is the mean expenditure of the customer who gets standard promotion. And what is mean expenditure of the customer who gets new promotion? It's $1,637.49. Now, which group of customers are spending more? Obviously, by looking at this, we see that the customers who are getting new promotion are spending more compared to the customers who are getting standard promotion. But you see, we can't conclude anything from this basic mathematical approach. Why? Because you see, here we are working with a sample, and on the basis of the sample, we will conclude about the population. So, concluding anything by looking at this mathematical mean is not conclusive enough. Okay, so that won't work. Okay, because we are working with samples. So what we need to do is that we need to go for a hypothesis testing, and here is the importance of statistics. Okay, so this is the reason why we cannot go ahead with this mathematical approach, because this being a sample, and that's the reason why statistical analysis are so important in making a decision. So I hope you understand the importance of carrying out a statistical analysis. So now you see, the thing is decided that we need to go for a statistical analysis, and here what we need to do, we need to perform a hypothesis testing, and in this case we will do a independent sample t-test. So finally we came to a conclusion that a hypothesis testing has to be done. Now, what is the first step of hypothesis testing? The first step is to define the hypothesis. Now, you see there are two hypotheses. One is the null hypothesis, another is the alternative hypothesis. Now, we would be using a lot of hypotheses in our coming examples. So, by the time we end this session, it would be a lot clearer to you. So, a null hypothesis is represented by H0 or H0, and our alternative hypothesis is H1. Now, in this case, what is the null hypothesis? So we need to formulate the hypothesis. So the null hypothesis is there is no significant difference in mean expenditure between these two types of promotion. So whatever difference you see out here, it's because of a chance. A significant difference does not exist. This is the null hypothesis. And what is the alternative hypothesis? The alternative hypothesis is a significant difference exists in the mean expenditure between these two types of promotion. So I will repeat myself again. The null hypothesis is there is no significant difference in mean expenditure between these two types of promotion, and the alternative hypothesis is a significant difference in expenditure exists between these two types of promotion, the standard promotion and the new promotion. So we have defined our hypothesis. Next is to fix up the level of significance. So we would be working with the 5% level of significance. So you can always work with 10% or a 1% level of significance. So it depends upon the researcher. But we would be working here with the 5% level of significance. And in our next examples or in our coming case studies also, we will be working with the 5% level. Now, if this level of significance I convert it into decimals, it would come to 5 by 100, which is 0.05. Now, there is something called the p-value. So, p-value is the also called the alpha value or the minimum value at which a null hypothesis gets rejected. So, you can just think it of like this, that if the p-value, because we are working with a 5% level of significance, if the p-value is less than 0.05, we accept the alternative hypothesis. If the p-value is greater than 0.05, we accept the null hypothesis. This is for 5% level of significance. So if it's suppose 1%, then it would be if the p-value is less than 0.01, we will accept alternative, and if it's greater than 0.01, we will accept null. So as we are working with 5% level of significance, I will again again say that if the p-value is less than 0.05, we accept the alternative hypothesis. If the p-value is greater than 0.05, we accept the null hypothesis. So you see the foundation has been laid. Now we can carry on with the test. So how to do it? Click on Analyze, Compare Group, T-test and an independent sample T-test. So I give an analysis title, independent. Take the variable as dollars, how much they are spending, and what is the factor, what type of promotions are being given. So level 1 is the standard promotion and level 2 is the new promotion. So I hope it's clear. So we want to check out how much dollar is being spent by the customers who are getting standard promotion and new promotion, and I click on OK. So here you see standard promotion in the group descriptive. What we saw, what was the mean expenditure for standard promotion is 1566.38, and the mean expenditure for new promotion is 1637.49. So out here you see what is the mean expenditure for the customers who are getting standard promotion is 1566.38, and what is the mean expenditure for the customers who are getting new promotion is 1637.49. Now what was our null hypothesis? The null hypothesis is there is no significant difference in mean expenditure between these two types of promotion. So whatever you see here is because of a chance. And what was our alternative hypothesis? The alternative hypothesis is that there exists a significant difference in mean expenditure between these two types of promotion. Now, how to decide whether to accept a null or an alternative hypothesis? We look at the p-value. So what I said, if the p-value is less than 0.05, we accept the alternative hypothesis. If the p-value is greater than 0.05, we accept the null hypothesis. So here you see the p-value, it's less than 0.05, so we accept the alternative hypothesis. And what is the alternative hypothesis? That there exists a significant difference in mean expenditure between the customers who get a standard promotion and the customers who get a new promotion. So if I am the analyst of the departmental store, what I will suggest? I will suggest that the store must roll out more of new promotion, because new promotion is bringing in more revenue and it is backed by a significant p value. So this you see is what an independent sample t-test is. Now, before coming to the conclusion, we have another table out here which is called the Levin's test. Now you see, whenever we are doing parametric tests, there are some assumptions. So make sure you go through all of the assumptions. They are very important. So assumptions of parametric test. Now, one of the assumption is called the assumption of homoscedasticity. So what does the assumption of homoscedasticity say? That the variance of the residual term should be constant. So that is the assumption of homoscedasticity. Variance of the residual term should be constant. So here you see we have the Levin's test to check out. Now you see we have a p-value. So whenever you come across a p-value in statistics, in the back end there is a null hypothesis and an alternative hypothesis. So you must know what is the null and alternative hypothesis. So you see for Levin's test, the null hypothesis is the variance is constant. The alternative hypothesis is that the variance is not constant. Out here you see p-value greater than 0.05. So we accept the null hypothesis that the variance is constant. So our assumption is satisfied. So this is what a Levin's test is. Okay, so make sure you know all the assumptions of the parametric test. So finally, we can conclude that the store will roll out more of new promotion because new promotion is bringing in more revenue compared to standard promotion, and it is backed by a significant p value. Now you see, if we come back to our data, we have two types of promotion, standard promotion and new promotion. Okay, and as I said you, no customer will get both type of promotion. either you get a standard promotion or you get a new promotion. So you see two independent samples are being created. So that's why it's called independent sample t-test. So that's why the name is independent sample t-test. So I hope it's clear. And lastly, coming to the definition, you can define it as the independent sample t-test is a test to check the hypothesis whether a significant difference in mean exists between the two independent samples. So my two independent samples here are standard promotion and new promotion. So I'll repeat myself again. An independent sample t-test is a test to check the hypothesis whether a significant difference in mean exists between the two independent samples. So this is what an independent sample t-test is. So I hope I was able to clear it out to everyone. So what's an independent sample t-test is, and I hope you got this case study. The next we will move on to the paired sample t-test. Okay, so this is the case study for the paired sample t-test. So you can just have a look at it. So I'll pause for some time. Okay, so I hope you have been through it. So I'll again explain the case study. Okay, so let's take the relevant data. So again, I click on view, click on tables. And I will take up the data where I will do a paired sample t-test. Okay, this is the one. Okay. So now you see in this particular case study, there is a physician who has come up with a new type of diet. Now the physician wants to check out whether this diet is effective in reducing the triglyceride level and weight of the patient. So the doctor wants to check out whether this diet is good enough in reducing the triglyceride level and weight of the patient. So this is the case study. So what the physician has done is that randomly the physician has selected 16 patients across different age groups and gender. And what the physician has done is that he has measured their triglyceride level TG0. So the 16th patient's triglyceride level is TG0. So after this measurement was taken, the patients were kept on diet for the next 6 months. And after the completion of the diet, the triglyceride level was again measured, which is TG4. So I hope it's clear. So before the start of the diet, the physician measured their triglyceride level TG0. So this is the triglyceride level for all the 16 patients before the diet. And for the next 6 months, the patients were kept on diet. And after 6 months, the triglyceride level is again measured TG4. The same has been done with weights as well. So before the start of the diet, the weight was measured WGT0. And after 6 months, after the completion of the diet, the weight was again measured, which is WGT4. So TG0 and WGT0 is triglyceride level and weight before the diet, and TG4 and WGT4 is the triglyceride level and weight after the diet. Now here you see we have a variable called difference in Tg. So difference means Tg0 minus Tg4. So Tg0 minus Tg4, you see in some cases the triglyceride level has fallen. In some cases, for some patients, it has increased. Similarly, difference in weight is WGT0 and minus WGT4. So you see in all the cases the weight has fallen. Now let's check out what is the mean difference. Mean difference in triglyceride level and mean difference in weight. So what we do, we'll just look at the descriptive. So click on analyze descriptive, give an analysis title, suppose mean. So variable is difference in Tg, difference in weight. Click on options and click on mean and click on OK. So you see by what average unit the triglyceride level has fallen. You see the triglyceride level has fallen by an average of 14.06 units and the weight has fallen by an average of 8.06 unit. So you see, we see that there is an average fall for both triglyceride level and weight for all the 60 patients. But again, you see, we cannot conclude anything from this mathematical approach. Why? Because this is only a sample we are working it. And to conclude about the population, we need the help of statistical analysis, and particularly here we need a paired sample t-test. So what would be the null hypothesis? The null hypothesis will be that there is no significant difference in mean triglyceride level has taken place, and for weight it would be no significant difference in mean weight has taken place. So this is the null hypothesis. And what is the alternative hypothesis? The alternative hypothesis is that a significant difference in mean triglyceride level has taken place and a significant difference in mean weight has taken place. Now, which hypothesis to accept? So we would be working with 5% level of significance. If p-value is less than 0.05, we accept the alternative hypothesis. If p-value greater than 0.05, we accept the null hypothesis. So I hope this part is clear. So let's proceed with the hypothesis testing. So click on analyze, compare group t-test and a paired sample t-test. So I give an analysis title, paired. I take up the variable one. So first let's do for triglyceride. So variable one is Tg0, which is triglyceride level before the diet, and variable 2 is Tg4, which is triglyceride level after the completion of diet. And what is my null hypothesis? No significant difference has taken place, and my alternative hypothesis is a significant difference has taken place in the mean triglyceride level. And let's click on OK. So here you see in the descriptive what we saw, that triglyceride level fell by 14.062 unit. The average fall was 14.062 unit. So here you see what is the mean of the difference? It's 14.062. So triglyceride level has on an average fallen by 14.062 unit. Now whether this difference is significant, for that we look at the p-value. Now you see what is the p-value? It's 0.24. So 0.24 is it's greater than 0.05. So if the p-value is greater than 0.05, we accept the null hypothesis. And what is the null hypothesis? That whatever difference you see out here is not significant. It's because of a chance. So this is the null hypothesis. And here you see we are accepting the null hypothesis because the p-value is greater than 0.05. So what we can conclude? We can conclude that this particular diet is not effective in reducing the triglyceride level because we are not getting a significant p-value. Now let's see what effect it has on weight. So let's run the paired sample t-test for weight again. So again, I'll just refresh it. So variable 1, I'll take it as weight 0 and variable 2 as weight 4. So weight 0 is before the diet, WGT4 is after the diet, and I click on OK. So you see what was the difference in weight? It was 8.062. The difference in weight was 8.062. So out here you see the mean difference, it's 8.062. It means the weight has fallen by 8.062 unit. Now again, what is the null hypothesis? That this difference is not significant, and the alternative hypothesis is this difference is significant. Now, whether to accept a null or an alternative hypothesis, what we do, we look at the p-value. Now, what is the p-value? So, be careful. Here you see the p-value ends with e to the power minus 8. Means it's very small, way smaller than 0.05. So, when the p-value is smaller than 0.05, we accept the alternative hypothesis. And what is the alternative hypothesis? That a significant difference in the mean weight has taken place. So what we can conclude? We can conclude that this diet is effective in reducing the weight because we are getting a significant p-value. So what will be our overall conclusion? The overall conclusion will be this diet is ineffective in reducing triglyceride level. It does not help in reducing triglyceride level. Why? Because we are not getting a significant p-value. But this diet is effective in reducing weight because we are getting a significant p-value. So this diet works good for reducing weight, but it does not work good for reducing the triglyceride level. Now you see, if we come back to our data, now you see we are comparing a pair of variables like TG0 and TG4, WGT0 and WGT4. We are comparing the mean of the pairs of the variable, and that's why you see it's called a paired sample t-test. So that's why the name comes paired sample t-test, because we are comparing the pair of a variable. Now, what would be the probable definition? The definition would be a paired sample t-test is a test to check the hypothesis whether a significant difference in mean exists between the pre and the post value. So you see pre value is TG0 and post value is TG4. Pre value is WGT0 and post value is WGT4. So again, to repeat myself, a paired sample t-test is a test to check the hypothesis whether a significant difference in mean exists between the pre and the post value. So this is what a paired sample t-test is. So I hope it's clear, the paired sample t-test. And now I think it's clear to you. It's clear to you what is the difference between an independent sample t-test and a paired sample t-test. Lastly, we'll come to the one sample t-test. So again, you can go through this case study once. Okay. So we will move on to the data. So again, I'll just select the data from my table section. You see, what is a one sample t-test? Let's take another example. Suppose there is a train which runs between Bangalore and Kolkata. So during this entire course of journey, the train can attain different speed. Like sometimes the train is running at 70 kilometer per hour, sometimes at 30, sometimes at 90, sometimes at 80, and so on. Now Indian Railway is claiming that the average speed of the train is 85 kilometer per hour. Now, how can we believe it? That whether what is being claimed by Indian Railway is true or not. So in that case, what we do? We can do a one sample t-test. So we'll compare the sample, which is the speed of the train to the during the entire course of the journey, to the claim that is being made by railway, which is 85 kilometer per hour. So this is the place where we apply a one sample t-test. So it also happens in manufacturing sector. Suppose there is a machine which produces screw. Okay, now a machine can produce thousands and lakhs of screw in a day. Okay, now the factory manager, the manager claims that the diameter of the screw is suppose 0.05 mm. Now how to understand whether what is being claimed by the manager or the engineer is true or not? So what we do, we take a sample of screws. Suppose we take 100 screws and we compare the diameter of those 100 screws with 0.05 mm, and we will see whether what is being claimed by the engineer or the factory manager is true or not. So these are the places where we can apply a one sample t-test. So out here you see we have a data for three companies, company 1, 2 and 3, who provide internet broadband services. Now you see, so we'll focus on company 1. So this is the download speed provided by company 1 during the entire course of the month. Now what company 1 is claiming that the download speed provided by us is greater than 9. So this is the claim made by company 1, and you can see out here the download speed during the entire course of month, and company 1 is claiming that the download speed provided by us is greater than 9. So how we can trust them? So being an analyst, what we can do is that we can simply go for a once. Can you please mute your mic? Okay, so being an analyst, what we will do is that we'll simply go for a one sample t-test. So before going to the test, what will be my null hypothesis? My null hypothesis is that the internet download speed is not greater than 9, and the alternative hypothesis is the download speed is greater than 9. So if the p-value less than 0.05, we accept the alternative hypothesis. If the p-value greater than 0.05, we accept the null hypothesis. Now let's carry on with the analysis. So we click on compare group, t-test, and the last one, the one sample t-test. So I give an analysis title, one sample. Take the variable as company 1. So we are comparing the speed of company 1. So what is company 1 claiming? That the download speed is greater than 9. So what is my null hypothesis? The null hypothesis is the download speed is less than 9, and the alternative hypothesis is the download speed is greater than 9. So having defined the variables, we just click on OK. Now here you see what is the speed with which the company 1 is comparing, 9. What is the estimated average? It's 10.33, and you see what is the p-value. The p-value is ending with e to the power minus 9, so it's far less than 0.05. So what we can say, so what hypothesis should we accept? We should accept the alternative hypothesis that the internet download speed is greater than 9. So what we can conclude? We can conclude that the claim that is being made by company 1, that is the internet download speed is greater than 9, actually exist because we are getting a significant p-value. So this, you see what a one sample t-test is. So we compare a sample to the test value. So what would be the probable definition? A one sample t-test is a test to check the hypothesis if a significant difference in mean exists between the sample and the test value, which here is 9. So we say yes, whatever company 1 is claiming is true because we are getting a significant p-value. Now this is what a one sample t-test is. So you see, we went through the three types of t-test: the independent sample t-test, the paired sample t-test, and the one sample t-test. And I think now it would be more clearer to you that based on the data you have, which type of t-test to apply. Okay, so these are the three types of t-test we have: independent, paired, and one. The next analysis we would do is the one-way ANOVA, or the one-way analysis of variance. So this is the case study. So you can just quickly go through it. It's pretty simple. Okay. So I'll quickly upload the data. You click on view, click on tables. And this is the data. Okay. So you see here, these are the variables present in our data set. It's from the biology field, from the field of botany. So you can just ignore log sepal, log petal length. So you see we have variables like what is the sepal length of a plant, what is the sepal width, petal width, and then species. So there are three types of species available, which is setosa, versicolor, and virginica. Now, in this case study, we want to see whether the mean sepal length differs across the three categories of species. So what we will do is that we will just do a quick recap of the independent sample t-test that we did earlier. Okay, so you see in this independent sample t-test, what we did, there were two types of promotion, a standard promotion and a new promotion, and we want to check out whether the mean expenditure differs between the two types of promotion, correct? So again, I would just repeat. So in the independent sample t-test, we checked out whether the mean expenditure differs across the two types of promotion. Now you see what happens when there are three types of promotion. Suppose the departmental store comes up with a standard promotion, a new promotion, and an X promotion. So there are now three types of promotion. So what to do now? We cannot use an independent sample t-test because here you see we have only two level 1 and level 2. So you can include only two promotion. You cannot include the third promotion. So what to do? So we switch to a one-way ANOVA. So one-way ANOVA is an extension of the independent sample t-test. So when you have more than two types of promotion, when you have more than two categories, you go to a one-way ANOVA. So coming back to my data set, so here you see we wanted to check out whether the mean sepal length differs across the three categories of species. So let's do a quick descriptive and then I'll explain it to you again in details. So we click on group descriptive. So I want to check out the group mean. So I take up the factor as species and the variable as sepal length. Click on functions and I want to check out the mean and click on OK. Now you see here, if you compare this with the independent sample t-test, species here you can think of as the type of promotion. So there are three types of promotion: setosa, versicolor, and virginica. So if you compare it with the independent sample t-test case study, and what is mean here is the mean sepal length. So you can think it of as mean expenditure. 5.006, 5.936, and 6.588. And we want to check out whether this mean is significantly different across these three categories. Now, why we did a one-way ANOVA? Because in independent sample t-test, you can have only two types of promotion. But here you see what we have three types. So that's why we are using a one-way ANOVA. So I hope it's clear why we are using a one-way ANOVA and not an independent sample t-test. So you see, in this case, what will be my null hypothesis? My null hypothesis is that there is no significant difference between these three categories, no significant difference in mean sepal length between these three categories. And what is my alternative hypothesis? My alternative hypothesis is a significant difference in mean sepal length exists in at least one of the category. So remember this part, I'm stressing on at least one of the categories. So I'll explain that later, what is the meaning of at least. So again, to repeat, the null hypothesis is there is no significant difference in mean sepal length across the categories, and my alternative hypothesis is a significant difference in mean sepal length exists in at least one of the categories. So if my p-value is less than 0.05, we accept the alternative hypothesis. If my p-value is greater than 0.05, we accept the null hypothesis. So let's start with the hypothesis testing. Click on compare groups, ANOVA and a one-way ANOVA. So we give an analysis title, one way. We take up the variable, sepal length, and the factor as species. In the option, again, you can check the Levin's test for homoscedasticity. So we'll not focus on this one. In the post hoc, I take Tukey's HST. Now, what is post hoc test? Again, I'll explain it later once we come across with the output. And finally, in the plot part, we can select a plot, like suppose a normal QQ plot. And in the plot color part, you can assign a color to your plot to make your plots more presentable. Having done that, just click on OK. So you see, in our group descriptive, this was the mean sepal length of the three categories. And our null hypothesis was there is no difference, no significant difference. And our alternative hypothesis is a significant difference exists in at least one of the category. So here you see, we get the ANOVA table. And what is the p-value? It ends with e to the power minus 31, means it's very small, way smaller than 0.05. So we accept the alternative hypothesis. And what is the alternative hypothesis? That the mean sepal length differs in at least one of the categories. Now, what is the meaning of this at least? You see, we'll look at the post hoc table. Now you see here all the categories has been compared among themselves. Now here we have a p-value. And as I said you, whenever you get a p-value, there is a null hypothesis and an alternative hypothesis. The null hypothesis is a significant difference exists in mean sepal length between the categories, and the null hypothesis is a significant difference does not exist between the categories, and the alternative hypothesis is a significant difference in mean sepal length exists between the categories. So out here you see, if we compare the mean sepal length in versicolor and setosa, the p-value is less than 0.05. It means the difference exists, significant difference exists. So we accept the alternative hypothesis. And you see for the others also, the p-value is less than 0.05. So we accept the alternative hypothesis that the significant difference in mean sepal length exists. Now you see, what was my alternative hypothesis in one-way ANOVA? That a significant difference exists in at least one of the category. Now you see, out of these three categories, out of these three comparisons, if in at least one we had a value of less than 0.05, this will be less than 0.05. The p-value in the ANOVA will be less than 0.05. Understood? So again, I'll repeat myself. So what was my alternative hypothesis in one-way ANOVA? That the mean difference in sepal length exists in at least one of the category. So you see here all the categories are compared. Suppose only in the first category the p-value was less than 0.05, and in the other two it was greater than 0.05. Still the p-value in the ANOVA will be less than 0.05, because the alternative hypothesis is it should exist in at least one of the categories. So that's why you see the post hoc table is so important, because in the post hoc table you can compare the categories as well. So which categories are actually different. Okay, so this is what a post hoc test is. So I hope this post hoc test is clear. So if you have some queries, you can just note it down, and in the discussion round, we can answer them. So this is what a post hoc test is. Then we have the diagnostic plot. So there is an assumption called the assumption of normality. So this is the QQ plot that we have. So if the points falls on this line, it means the variables are normally distributed. So we also have some statistics to check it. We have different tests of normality to check whether the variables are normally distributed or not. So we won't get into that part, but techniques are available in STATCRAFT. So you see, this is what a one-way ANOVA is. So the definition would be the one-way ANOVA is a test to check the hypothesis whether the significant difference in mean exists across the categories of an independent variable. Okay, so this is what is a one-way ANOVA. Next, we will move on to the predictive modeling, which is the correlation and regression analysis. So you can just have a look at this. Okay. So I hope you're not finding the session boring. So we have tried to keep it as interesting as possible. So we'll take up a data for correlation and regression. Okay. So here you can just ignore these fitted values. So suppose if you want to remove unwanted variables from your data set, what you can do is that you can just move on to the meta section and you can just delete the unwanted variables. Okay, so I want to delete this. So these are the results from my previous analysis I did. Okay. Now you see what we want to do out here is a correlation analysis. So this is a data from the economic sciences. So here we have different variables like gross national product, deflator, gross national product, what is the unemployed rate, armed forces, population, year, what is the employment level, and so on. Now the first what we want to do is that we want to do a correlation analysis. So what is correlation? So correlation measures or captures the degree of association between two variables, and a linear relationship is captured. So correlation doesn't capture a non-linear relationship. It will capture a linear relationship. Now you see the value of correlation coefficient ranges from -1 to +1. Okay, so when suppose let's take variable demand and price. So when price increases, demand decreases. When price decreases, demand increases. So what we see is that when one variable increases, other decreases. Okay, so if we plot it in a graph in an XY axis, we will get a downward sloping curve, because when one is increasing, other is decreasing. And what is the slope of a downward sloping curve? It's negative. So the correlation coefficient will also be negative. So when one variable increases, another decreases, or when the variable moves in the opposite direction, we get a negative correlation coefficient. Similarly, let's take another example, supply and price. When prices increases, supply increases. When prices decreases, supply decreases. Obviously, other factors remaining constant. So in that case, you see, if you plot it in a graph, you will get an upward sloping curve. What is the slope of the upward sloping curve? It's positive. So what is the correlation coefficient? The correlation coefficient is also positive. So when variable move in the same direction, we get a positive correlation coefficient. When variable move in the opposite direction, we get a negative correlation coefficient. So let's check out what is the correlation coefficient between all of these variables. So how to do it? We click on analyze, regression and correlation. So we give an analysis title, correlation. So you can perform different types of correlation like Pearson, a Spearman or a Kendall based on the type of data you have, a variable you have, and I click on the variables. So I select all the variables. So I want to create a correlation matrix. Next we click on Splom chart. So Splom chart is the scatter plot matrix. So it will give you the scatter plot for all the combination of the variables. Can increase the size to make it more visible, and finally in the color part you can assign color to the different parameters that are being used. And having done that, just click on OK. So here you see this is my R code for the correlation matrix. So this is the R code for creating the data frame. So as we have seen yesterday, you can copy this, you can reflect it in R, and you can start learning to program in R, start to learn how to program in R. And this you see is the R code for getting the correlation and significance matrix. So one point to note out here, you see before the double colon, the name of the package is mentioned. Okay, so as we have seen yesterday that there are numerous package available in R. So there are over some 11,000, 12,000 packages in R. But you see in StatCraft, whatever package is being used in the back end, all of it is being published in the output so that the user has a clear understanding about the working of R. So if you want to reflect the same analysis in R, first you need to install this particular package in R, and then you can copy and paste this code in the R console. So here you see we get the correlation coefficient. So what is the correlation coefficient between gross national product and suppose armed forces? So you see it's positive. It means when gross national product increases, the number of people in the armed forces also increase. So what is the correlation between population and armed forces? So you see again it's positive. It means that when the population increases, the number of people in the armed forces increases. So this is how you interpret. So based on minus and plus, you can decide whether when one variable increase, other will increase or decrease. And here you see we have the significance or the p-value. So as I said you, whenever p-value, you will have a null and an alternative hypothesis. So the null hypothesis is there is no significant linear relationship between the variable, and the alternative hypothesis is a significant linear relationship exists between the variable. Now you see based on whether to accept, based on the p-value, you can decide whether to accept the null and the alternative hypothesis. So I won't get into this part because I think by this time it's clear when to accept a null hypothesis and when to accept an alternative hypothesis based on the p-value. So this you see is what the correlation analysis is. And finally you see we get this Splom chart, which is the scatter plot for all the variable in a single diagram. So like here you see it's upward sloping. Upward sloping means what? When this is increasing, when GNP deflator is increasing, GNP is also increasing. So you see both are increasing. So this will have a positive correlation. Out here you see population and year. This is also upward sloping. It means when year is increasing, population is also increasing. And here you see by looking at the scatter plot, you can understand whether the variables are positively correlated or negatively correlated. Okay, so what a Splom chart is. Next, we come to the regression analysis. So regression is the stepping stone to predictive modeling. Okay, so in regression, what we do is that we predict. So suppose here we want to predict employed based on these independent variables, GNP deflator, GNP, unemployed, armed forces, population, and so on. Okay. Now you see a regression equation is of the form y equals to a plus bx. A mathematical linear equation is also of the form y equals to a plus bx. So what is the difference? Let's take an equation y equals to 2 plus 3x. So you see in case of mathematical equation, when x is 1, what is y? Y equals to 2 plus 3 into 1, which is 5. When x is 2, y is 8. When x is 3, y is 11, and so on. So you see, when x is 1, in case of mathematical equation, y has to be 5. Y cannot take any other value. So this is what a mathematical equation is. Mathematical equation is a deterministic equation. Whereas if y equals to 2 plus 3x is a regression equation, when x is 1, y can take any value other than 5. And in a very rare situation, y will be equal to 5. Why? Because in regression equation, you have error. So that's why we say regression as a predictive modeling. So you are predicting something. So a regression equation is not deterministic, whereas a mathematical equation is deterministic. So this is the difference between a regression and a mathematical equation. Now in this particular case study, we want to predict employment or employed based on these variables: GNP deflator, GNP unemployed, and so on. So how we do it? We click on analyze, regression, linear regression. We give a analysis title, regression. I take up the dependent variable as employed, and then I take up all the independent variables. Next, I click on options. So you can use different algorithm like a forward selection, a backward elimination, or stepwise. So if you don't have a knowledge of this, nothing to worry. It's very easy. You can just refer some videos or some articles. You will understand what these different algorithms are. So as of now, we will focus on the direct OLS method, ordinary least squares. And these are the different diagnostic checkings available. So you can select it as per your requirements. In the plot part, again, you can check out the normal QQ plot, and these are the different plots that are available. In the save part, you can save the fitted values and the residuals, which gets reflected in the data sheet. In the model, you can save the model for further use. And finally, in the plot color part, you can assign a color to your plot. Having done that, just click on OK. So here you see, we get the R code for the LM model. Okay. So you see here, employed is my dependent variable, and GNP deflator, GNP unemployed, and so on are my independent variable. Now this is my model summary table. So here you see we get an R square value of 0.995, which is 99.5%. It means that suppose if employment changes by 1 unit, 99.5% of the change is explained by these variables, and 1% is due to some other factors. So the R square value will range between 0 and 1, where 0 means 1%, 0 means 0%, and 1 means 100%. So we always aim for a high R square value. And adjusted R square is, suppose you build up multiple models. So in some models you take 4 independent variables, in some models you take 5 independent variables. Now based on R square, you can decide which model to choose. So you choose the model with the highest R square value. Okay. Next we have the coefficient table. So you remember that we use the equation y equals to 2 plus 3x. So here y is the dependent variable and x are the independent variable. So in this case, y will be employed and x will be GNP deflator, GNP unemployed, and so on. So what will be the equation? Y equals to, means employed equals to 2. So here what is 2? Minus 3482.25. So employed equals to minus 3482.25 plus 0.01 into GNP deflator plus minus 0.03 into GNP plus minus 0.02 into unemployed plus minus 0.01 into armed forces, and so on. So this is how you create your regression equation. And here again you see we have a p-value. So p-value means there is a null and an alternative hypothesis. So what is the null hypothesis? That these variables are not contributing towards the dependent variable, and the alternative hypothesis is the variables are contributing towards the dependent variable. So here you see GNP deflator, GNP, and population have all p-values greater than 0.05. So GNP deflator, GNP, and population are not important. So they can be removed from my equation. So in the later part, we will remove this variable from our equation because the p-value is greater than 0.05. Okay, I hope it's clear. Again, ANOVA. So in ANOVA, the null hypothesis is for regression equation, the model is not a good fit, and the alternative hypothesis is the model is a good fit. So here you see the p-value, it's less than 0.05. So what we can say, we accept the alternative hypothesis that the model is a good fit. This thing we can skip. Next we have the DW statistics. Now what is the DW statistics? Let's look at data. So you see employed here, we get the observed value. So 60.323 is the observed, which is the actual value. And this is the one which is being fitted by the model, 60.05. So the difference between these two is the error or the residual. Okay, so here you see we get the residual for all of this. So 64.98 minus 65.15 is minus 0.16. So these are the errors. Now, what is the Durbin-Watson test? So there is an assumption called the assumption of autocorrelation. So it says that these residual values cannot have a linear relationship between them. So that is the assumption of autocorrelation. So there cannot be any correlation, significant correlation between this residual term. Okay. So you see in case of Durbin-Watson statistics, my null hypothesis is, in case of Durbin-Watson statistics, the null hypothesis is autocorrelation is absent. Alternative hypothesis is autocorrelation is present. So here you see we get the p-value greater than 0.05. We accept the null hypothesis that autocorrelation is absent. So there is no autocorrelation. So my assumption is satisfied. The next we have VIF, which is the variance inflation factor. Now, what does it mean? There is an assumption called the assumption of multicollinearity. Now, what does it mean? It means that this independent variable cannot have any significant correlation between them. That is the assumption of multicollinearity. So, if VIF is greater than 10, multicollinearity is present. If VIF is greater than 100, severe multicollinearity is present. Okay, so out here you see the VIF are far greater than 100, so severe multicollinearity is present. So assumption is getting violated. So one of the way to rectify this is to remove the unwanted variables. So we saw that GNP deflator, GNP and population were having p-values greater than 0.05. So those were not required in the equation. So they are not contributing to the models. As a result, you see we are getting very high VIF, greater than 100. So to rectify this problem, what we will do is that we will run the regression model again, but now we will remove this GNP deflator, GNP and population, because what we saw that they were not contributing to the model based on the p-value. And we will just click on OK. So our aim was to reduce VIF. So now you see the VIF, it has drastically fallen, far less than 10. And the assumption of multicollinearity has been satisfied. Similarly, in the variable importance, you can see which variable is the most important variable in determining the level of employment. And finally, the diagnostic plot to check out whether your variable is normally distributed. Now this you see is how we do regression using STATCRAFT. Okay, so we must be very much cautious with the assumptions, whether the assumptions are being met or not. So make sure before doing regression analysis, you must go through all the assumptions. Okay, we must go through all the assumptions and we must see whether the assumptions are being met or not. So this was all in this session. Okay. Now see quickly I will take you through one of our new product. So you see this R has been there for a while, which is being widely used for doing statistical analysis. But you see there is a huge demand for machine learning that has come up in recent times. So everywhere you see in YouTube, in papers, everywhere people are now into data science, where learning machine learning algorithm is very important. So the advantage of machine learning algorithm is that the accuracy rates are very high when you apply machine learning algorithms to your data set. Now, one of the most favored programming language for running the machine learning algorithm is the Python programming. So of late, Python has been immensely popular because of the ease with which the machine learning algorithm can be implemented. But again, you see, one of the major challenges of Python is that being a coding based software or a coding based language, the learning curve is pretty steep. Okay, so a user has to be a very skilled coder in order to implement the machine learning algorithm using the Python programming. So to make Python accessible to the masses, we have came up with our other product, which is called the STATCRAFT P. So here P stands for Python programming. So the flavor remains same as StatCraft R. You don't have to write a single line of code, yet all your analysis will be done using a menu-driven interface. And in the output, you will get access to all the Python codes that are being used in the backend. And StatCraft P has been built up to focus on the machine learning algorithm, although we have provided a range of general statistics. So quickly, I'll take you through the software. I'll not take much of your time. So the flavor remains the same. It's a browser-based software. You just need to provide a user ID password. No installation required at the individual level. So here you see the interface. This is same as StatCraft that we saw for the last 2 days. Okay. And again, it's made in India product with the team working out from Bangalore. And what are the different analysis that can be done? So we have data where you can import from database, the data preparation techniques. We have the range of descriptive statistics available. In compare groups, we have the parametric as well as the non-parametric test along with the multivariate analysis. Then we have the different tests of normality, the regression models, linear and logistic. Then we have dimensionalities where you can do the factor analysis, PCA, linear discriminant analysis. Then we have the clustering algorithms, the graphical analysis, and the major crux of this software is the machine learning. So you see within the machine learning, we have the MLP classifier and regressor. So MLP means the multi-layer perceptron model, which is the neural network, popularly known as the neural networks. Then we have decision tree classifier, decision tree regressor, support vector machines, naive Bayes, and random forest classifier and regressor. So you see by just applying a menu driven approach, you can implement this machine learning algorithm in your data with very much ease. So just to give you a quick overview how things are done out here and what is the flavor of the software. So I'll just click on the source mode to upload a data. So you see this is the data I'll be working on. Okay, so I'll just remove the unwanted variables again. So I just click on meta and I'll just remove these variables. Okay, so you see in this particular analysis, in this particular data, we want to do a credit risk analysis. Okay, so default here means if given a loan, whether the customer will default or not. 0 means the customer will default, 1 means the customer won't default. And we want to develop an algorithm based on the variables income, debt income, credit debt, or other debt. So these are the variables I will use to build up an algorithm to decide if given a loan whether a customer will default or not. So basically this is a credit risk analysis. So suppose if I'm using the general statistics, what is the probable technique I would use? I would use a logistic regression to check out whether the person will default or not if given a loan. But you see, once I shift to the machine learning domain, and if if I'm greedy for a higher accuracy, I will always implement a machine learning algorithm rather than a logistic regression. So you see, in this case, suppose I want to apply a random forest method. So a random forest classifier. So we will use a random forest classifier when your dependent variable is categorical in nature, and a random forest regressor when your dependent variable is scale in nature. So you see, random forest is based on decision tree. Okay. So when we are using decision tree, we use a single decision tree. But in random forest, you can use hundreds and thousands of decision tree. So that's why it's called a forest, because a forest is composed of many trees. Similarly, a random forest is composed of hundreds and thousands of decision trees. So you see, your accuracy level increases to a great extent. So I will do the same. I'll do this analysis using random forest. So I take up the dependent variable as default, and I take up income, credit debt, and other debt as the independent variable. Next, I click on parameters. So you see, these are the range of parameters that you can set up. So you see, for the number of trees, suppose I want to use 300 decision trees. So I want to build up a model where in the back end, 300 decision trees will be used. So you can think the accuracy that it can attain. Then you have all these parameters. So we have a parameter called complexity, which is also called the learning rate. So if you go through the theoretical part, you will understand what all these parameters are. And you see, you can build up multiple models by tuning your parameters multiple times. And you can select a model which best fits your criteria. In the option part, again, there are different criteria, these different methods that you can fix up to build up your model. And finally, in the save part, you can save the predicted values and the probabilities. And having done that, you can just click on OK. So here you see, these are the range of Python libraries that has been used. So we are using pandas, we are using NumPy, and then we are using the scikit-learn. And as we have seen in R also, all the Python codes are provided. You can copy this, you can reflect the same analysis in Python. So you see the codes, the libraries are provided. What are the libraries that are being used? What is the data frame? The data has been divided into a training and testing set. What is the algorithm for the random forest classifier? So you see the range of coding that has to be done in order to implement a machine learning algorithm. But you see, by using STATCRAFT, all these hassles has been removed. You can just focus on your analysis and your output. So this is the best part with StatCraft P. So here you see, we get the confusion matrix for the training as well as the testing sets. Okay, so you see the number that has been incorrectly predicted are 136, and in testing it's 47. So this is the feature importance, and then we get the classification reports for testing. So you see, if we come to the data, so this is our data set. So I'll do one thing. I'll just rerun it again. I'll just missed some of the parameters. Okay. So as we see out here, that whatever output you get are all accompanied by the Python code, and that's how you can very easily implement a machine learning algorithm using StatCraft P. So this is the latest offerings that we have. So before ending, I would just like to draw your attention to our website. In the meantime, the feedback link has been shared in the chat box. So do remember to fill in the feedback form so it would remain active for the next 15 or 20 minutes. Okay, suppose that the link will be closed. So do remember to fill in the form. Okay, I'll just open up this website. Here you see, this is the website for StatCraft. statcraft.in. So you can always click on the event page and you can check out the upcoming events. So you can also visit our Facebook page to which will keep you updated of the events that will come up from time to time. And also, if you want a trial license for StatCraft, you can always click on the contact us button. You can fill in the inquiry form and you can just submit it. And within a couple of days, you will get access to the trial license for StatCraft, which will be valid for a period of 14 days. And in case you have any queries related to StatCraft, you can just mail us at this ID sales@statcraft.in, or you can just call up in these numbers that are there in the website if you have any queries related to StatCraft. Okay, so with this, I would end it here. So now if you have any queries, you can please post it in the chat box and we can have a discussion. So thank you everyone. Thank you for your patience. And again, please fill in the feedback form that has been provided. So it would remain active for the next 15 minutes. Okay. So do remember to fill it.
Shubhadeep, I think
Yeah.
some of the participants have query regarding when they will be receiving the certificate. So if you can just elaborate on that, and few queries are also there, if you can just look into them.
Okay, so you see, once you fill in the feedback form, the certificate will be issued by the organizing department. So it will take a couple of weeks. Okay, so please be patient. So within a couple of weeks, the certificates will be dispatched, hardly 1 or 2 weeks. Okay, but remember to fill in the feedback forms with the correct spellings and details. Otherwise, those same things will be reflected in your certificate. So be careful with the submission. And regarding the query, so we have one of the query: what is the use of linear regression? So you see, linear regression is for predictive modeling. So if you want to predict something, the first tool that you have at your disposal is linear regression. To just give you an example, suppose you have data on advertisement and sales, and you want to predict sales on the basis of the amount spent on advertisement. So in that case, you can use a linear regression. So linear regression is a predicting thing. So when you want to predict something, can we do ARIMA StatCraft? So yes, ARIMA is available. So it was not within the scope of this session, so we didn't get into the time series analysis. But yes, you see, we have the options of ARIMA available in StatCraft. So we have the options, all these things. So ARIMA is there in StatCraft. So time series modeling can be done. So in time series model, we have simple exponential smoothing, Hall's method, Winter, ARIMA, and then we have the different plots that are available. So there is a question: how can we estimate the parameters in our software for a single data set? So you see, this part was covered in yesterday's session. So I'll just click on the outputs. So here you see, this was the R code for creating the regression model. So here you see we had this many variables. So if you have only one independent variable, you can just end your code here and then you can type the method and the model. That's it. Okay, so the videos will, the session videos will be shared. So do remember to join the Telegram group. So we would be sharing the video link for both the session, yesterday's and today's, in our Telegram group. Probably tomorrow we'll be selecting, so you can download the videos from there. So the link for the videos will be selected, will be shared in the Telegram group.
Please note that the feedback link has already been shared, and we will be closing that link very soon. We are almost done with the session. So requesting all participants to fill in their details and The certificates will, as Shubhadeep has already informed, the certificates will be mailed across to you within probably a week's time. You will not be getting it immediately. It will take some time to reach you. Okay. So please do see the feedback form link in the chat box and fill it up as we are towards the end of the session. And if you have any further queries, please post it, or you can unmute yourself and talk to us as well.
Okay, there is a question. What is the name of the Telegram group? So you see in the brochure, there is a link which you can click on it and you can join the Telegram group. So the brochure that you have, a link is provided for Telegram. So you can click on it and you can join the group. So any more queries? You can write it down in the chat box. Okay, I'll be sharing the Telegram group ID. Just a second.
If anyone has any further query, you can unmute yourself and talk to us as well. Or else you can write it in the chat box. We'll be happy to answer your query.
Okay, how do I know which regression equation is suitable for the particular data set? Now you see, you go with the regression equation where you get a good value for the statistics, like R square, adjusted R square. So based on that, you can decide which regression equation to go ahead with. So that depends again on the researcher or the user. So the Telegram link has been shared. You can join the group using the link. So the videos will be shared in the group. Any more queries, anyone?
Sir, do you have any books for learning the basics, sir?
The basics of statistics?
Maybe coupled with R as well.
Okay.
Or through Google can do it, sir.
So you see what the problem of our learning from Google is that as we have shown you that R has multiple packages. Okay, and this a multiple package can be used to run a regression model. So which package is the best package to use? That again requires some research work at the back end. Okay, so you can learn it from Google, but you need to be very careful with whether the appropriate packages are being used or not. Okay, so that is one of the major challenges of learning R from an open source like Google.
Thank you, sir. Could you recommend any one book maybe where we can learn the basics of R?
So there is a book of the publication called O'Reilly, Reilly. So this is the name I can think of as of now.
Okay, okay,
Okay, so where you can start with the fundamentals of learning.
okay. Something if you come across also, kindly post it maybe the tomorrow's Telegram link, sir.
Sure, sure. I will post the name of the books in the Telegram group. So as of now, I can't recall the names, so I will share it there.
Thank you, sir. Sir, one more thing, we are working in colleges. How do we take it to the student level, sir?
Like you want to take what to the student level? Like if you can elaborate.
Maybe usage, application of the R, and what role, of course, can play. Maybe that is what, sir.
Okay, so you see, this StatCraft has been built up keeping in mind the academic fraternity. Okay, because what we came across from our initial research that teaching programming to students is a pretty difficult task, okay, because there are a lot of theories that has to be covered, and if it's coupled with the programming part it becomes very hectic. So you see, this statcraft was built up to introduce R programming to the students. Okay, so as you saw that in statcraft, using a menu driven approach, the student can get a good exposure to the R programming language, and by using a menu driven approach they can self learn R from this particular platform. And that's how you see we are making, that's how statcraft has been made to make R more accessible to the masses, and that the student can pick up R from this very platform with a minimal guidance from their professors. Okay, so statcraft will be a good platform to introduce R to your students.
Sir, suppose since we have three PGs, I'm working for Kannur College of Technology, Coimbatore.
Okay.
We have three PG programs. Can we make a request to give us a demo or maybe the explanation students? Would you please able to support us, sir?
Sure, sir. What you can do is that you just drop a mail here, sales@statcraft.in, or you can get in touch. You can just get in touch with these numbers, and accordingly we can take it ahead.
Thank you. Thank you very much.
Okay,
Thank you
so
very
you
much.
can just drop a mail in this one.
Thank you, sir.
Okay,
Thank you. Thank you very much.
thank you.
Shubhadeep, I think we can end it here now, or if you have anything.
Okay. So,
meeting.
Dhanavandhan sir, if you want to conclude the session, so
Yes, sir.
over
Yes,
to
sir.
you.
Yes, sir.
Over to you.
Okay. Just a minute, sir. Oh, 5 minutes. I another meeting, sir. I wind up commit, sir. Please.
So we have a single feedback link for today. Yesterday we didn't have any feedback link. So for any queries, I've shared the email IDs and phone number, so you can get in touch with us. So I've shared it in the chat box.
Thank you. Hello, sir. Audible, sir.
Yeah.
Hello. Sir, sir, is hearing my voice, sir?
Yeah, you're audible.
Yes, sir. Yes. Thank you for today's sessions. We learned a lot of source code and script associated with R softwares and the based on web application of you are associated with the StatCraft. The big domain of StatCraft is very useful nowadays. Is digital world the very intuition of situation. The ICT applications, government of India is promoted to ICT application.
Excuse me, sir.
Okay,
Yeah,
that is a very important.
actually I have one queries.
Okay, discuss with you. You ask the.
Okay. Hi Suvadip, this is Lakshmi. Actually, I just wanted to know this StatCraft. I mean, this web-based R code. Is this free access? Like, or it's needs some subscription or minimum cost for this?
No, this is a proprietary product. So StatCraft needs to be purchased by the organization, institutes, university. So it's not for individual sale, and it's not a free product. It's a proprietary product.
Okay. And I mean, whatever. Yesterday
ரெண்டு
I didn't.
போட்டிங்களாப்பா எல்லாம் வாட்ஸ்அப் குரூப்லையும் வந்துருச்சுங்க செக் பண்ணிக்கோங்க
Yeah, I
எல்லாம்
mean,
வாட்ஸ்அப் குரூப்லைங்க
I attend today's session and
பைத்தானு
have got
3
to know
எஸ்எஸ் கலர் 2
that it is like
இன்டர்நேஷ்னல் webinar
if anybody is not,
இன்டர்நேஷ்னல் webinar
I
5ங்க
mean,
4ங்களா
sir, could you please mute yourself?
ஓகே
I mean, if anybody is not comfortable with any of the programming language, then he can like use this R code, web-based R code. I mean, easily.
Yeah.
So I mean, any suppose you want to customize some of the algorithms. These are some of them are existing algorithms. Then
Yeah.
suppose you want to customize based on your application. In that case, I mean, is there any provision in the StatCraft so that you can customize your, I mean, mathematical modeling or something in that case?
Okay. So you see customization, a user cannot customize StatCraft. Okay. So suppose the best thing with StatCraft is that you can customize this software. So suppose if there are some techniques that needs to be added, you can always place a separate order and those things can be integrated with your licenses. So customization can be done, but only the company can do it, not the user or the end user.
Okay. Thanks, Suvadip. It's, I mean, a very interesting session.
Thank you.
And it's quite refreshing for me. Yeah, thanks.
Thank you. Yes, sir. Please carry on. Dhanavandhan, sir. Gandhiya Vendhan, sir.
yes sir. Dear delegates, any queries, any doubts? If you possible to discuss with the StatCraft's statistician resource persons relevant to software and any statistical application domains. Okay. Sir, let us start my vote of thanks. Okay. Sir,
Okay,
I will
sir.
start my vote of thanks. Thank you for giving the opportunity of my authority of Honorable Vice Chancellor, most respected Registrar, respected Professor and Head Dr. R. Vijayaraman sir, Professor Jayasankar sir, Professor Muthukrishnan sir, Professor Satyavel sir, and my colleagues Dr. Kavyas, Dr. Pradipha Veerakumari and Dr. Jayalakshmi, and my research scholars, Department of Statistics, faculties, other guest lecturers. I happy to see the successfully completed this program. Last 2 days, National Visual Programs webinar of data analytics in R using StatCraft. And my personally thanks to the yesterday resource person Surya Sen Das, statistician, StatCraft from Bangalore. Today's session, Subhadeep Day, statistician from StatCraft Bangalore. And once again, thanks to StatCraft Incorporate of corporate sectors of software industries. And my dear delegates of professors, scientists, research scholars, students, and another peoples, others of industry peoples. Thank you, sir. Thank you for supporting for StatCraft and our university authorities. Thank you, sir.
Thank you, sir. Thank
Thank you
you.
so much,
Thanks,
sir.
sir.
Thank you for having us here, sir. Thank you so much.
Thank you, sir.
Subhadeep
One
will be
more
ending.
things. Other information is already post Google Meet of already link is opened. Please join. The professor is retired persons. Professor A. Rajagopal, former head, Indian Statistical Institute, Coimbatore. He is of done of case studies is healthcare, any industries, IIT, ITS, engineering, science and technology relevant of process. Join to the sessions. The session of topic for approach to blind data through data mining techniques. The based on case studies, real time of applications. So all of kindly join the link. Okay. Thank you, sir.
Thank you so
Thank you
much,
very
sir.
much, sir.
Thank you so much. We'll be ending the session here, sir. Thank you. Thank you.